Good morning, Year 7. I hope your day's going well for you. Today we're going to look at some geometry. So the topic is vertically opposite angles and angles at a point. And what I've done here is I've taken an extract from Maths Online, which is where you're going to be doing your work for this lesson. Now, here are the two key ideas: vertically opposite angles and angles at a point. So what is a vertically opposite angle? So a vertically opposite angle, in this case here, this angle here and this angle here are vertically opposite. And this angle and this angle are vertically opposite. How do they arise? They arise when we take two lines that join together, and we can see these two here, which we call vertically opposite, and these two here, which we call vertically opposite. Now, there's a very special property about vertically opposite angles, which is that they are always equal. And Maths Online has very kindly put that for us in a box here. Vertically opposite angles are equal. So here's a really simple example of a very simple problem. They're giving us two lines. There's a 70-degree angle there, 70-degree angle there, and then they're asking us, what is this angle? They're using a bit of algebra, m. So what is m? And the answer is, here's the answer, m is 70. Now, there is actually a little bit of reasoning going on here. The student has realized our vertically opposite angle and has told the reader these are vertically opposite angles. And then they've used this symbol, therefore, dot, 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 as a little triangle. So because they're vertically opposite, m is equal to 70. So a very simple introductory Year 7 answer would just be m is equal to 70 degrees. A more advanced answer would be to write they are vertically opposite angles. So actually write the sentence, vertically opposite angles, like that, vertically opposite angles, and therefore m equals 70, like that. All right, the other part of this lesson is to understand that angles at a point, that's a very classic expression, angles at a point add to 360. So there's the point, and you can see if we go all the way around like that, we must have 360 degrees. So reading it, these three unknown angles, A, B, and C, if we add them together, are 360 degrees. So here's a very simple problem. We have 140 degrees, a 90-degree angle, which we know from the right angle marker, right there, and this unknown x. And how do we find the x? Well, we could say, oh, that must all add up to 360. In your head, you're going to go, or with a calculator, that's okay. You're going to go 360, take away 140, take away 90, is leaving 130 degrees. Notice their answer. They've actually said angles at a point add up to 360. Therefore, x equals 130. Here's a slightly harder one now. Can you see the vertically opposite angles? Yeah, they're clearly vertically opposite angles. So that must be 58. That must be 58. Now look at the reasoning here. It's a little bit different. M plus 25 is equal to 58. That's what we see. We know that M plus 58 must be, M plus 25 must be 58. And then here what we've done, I'm not a big fan of how Maths Online have done this. They've used abbreviations. They're saying the reason why, because it's vertically opposite angles. We actually don't really like that. It's a little bit too lazy. So we prefer you to write vertically opposite angles. And as a consequence of that, well, if m plus 25 is 50, and always we like the reason in brackets. Can you see how I put the reason in brackets? And as a consequence of that, well, m plus 25 is 58. What must m be? Well, it's going to be 58. Subtract 25. Oh, now we're coming into some algebra. So check this one out. We've got 110 degrees here. We've got 4 x's here and 6 x's here. So all of them together must be 360. So this is the first line of reasoning. 4x plus 6x plus 110 is equal to 360 degrees. Why? Because they are angles at a point, and we would much rather you write angles at a point. Yep, write it nicely. Angles at a point. Now we're going to do a little bit of algebra. And fortunately, we have done enough algebra to know that 4x and 6x is 10x. So that means 10x plus 110 is 360. So that plus 110 is that. So 10x is actually 360. Take away 110. It's 250. Now, if 10 lots of x are 250, then one lot of x, well, it's going to be 10 divided by that is that. That's going a little bit fast. I might actually write it like this. 4x plus 6x plus 110 equals 360. 10x equals 360. Take away 110, which is equal to 250. That's 10x. So therefore, x must be 250 divided by 10, which is 25. That's a much harder question because it's got some algebra in it. And here again, we should write nicely, angles at a point. That's our reason. That's verging on a year 8 level geometry question. Finally, let's look at the hardest one in the Maths Online examples. Ooh, 2 letters. So we've got to look very carefully at what we can do. Look at that. That's 180. But that's not helping me because I've got 2 things I don't know. Oh, but if I look this way, let me rub out the other one. So if I look down, it's kind of a bit like a crossword puzzle. Now I can work out what A is. So 80 plus 50 plus A must be 180. There it is there. A plus 50 plus 80 is 180. And the reason? Angles on a straight line. Notice the format. We write an expression in algebra often, and we say y, angles on a straight line. And then we have to do a little bit of work. Now, depending on how good your algebra is, you may or may not be able to do that, but I think you can work it out. And then this is a 2-step one. So now that we've worked out that's 50. Oh, actually we could get 80 right there. There it is. They're vertically opposite. Can you see that those 2 angles are vertically opposite? This one and this one, they're actually vertically opposite. So we can get them straight out. And there it is. B is vertically opposite. And that is about as hard as they're going to get, that we would expect most students in Year 7 to be able to do. So I have set you an assignment in Maths Online to do some practice of those. Please do that assignment very shortly. Before we finish though, we're going to explore the really interesting question, yes, but why? And I'm going to save that for the next little video.